So let's begin with alcohols. Alcohols are a group of organic compounds that contain the functional group called hydroxy or hydroxyl group with the formula single bond oxygen with carbon, also single bond with hydrogen. Okay, the simplest alcohol has one carbon called methanol. The OL here in red font is for the nomenclature according to the IUPAC system. So we use suffix OL to give the name of the alcohols. So again, the one carbon simplest alcohol is called methanol by the IUPAC system. So it has one carbon bonded with three hydrogen here. For the ball and stick structure, this red sphere or ball represents the oxygen atom. So that oxygen atom is single bonded with hydrogen and also single bonded with carbon. Okay, this one is the complete structure, and this one is the line angle formula or bond line structure. The one here below is the condensed formula of the alcohol. Molecular formula will be, so again for the molecular formula, you indicate the kinds of atoms. So we have carbon, hydrogen, and oxygen. So in molecular formula, we begin with indicating the number of carbon, hydrogen, and the atom or atoms. So in this case, we have one heteroatom, oxygen. So how many carbon are there or is there? We only have one. So for one, we no longer indicate subscript 1, that is understood, that is given. For hydrogen, we have a total of 4. 3 are bonded. 3 are bonded with carbon and 1 with oxygen for a total of 4. And then we have 1 oxygen, so we don't need to indicate subscript 1, that is understood. So again, this is the molecular formula. The second simplest is ethane. So you just need to add another carbon. You use the prefix eth to indicate that there are 2 carbon atoms. So we will just have here an additional number of carbon, so that for the condensed structure we will have CH3, CH2, and OH. And then for the molecular formula, we will have C2H6O. So you just added more atoms of carbon and hydrogen. For the line bond structure or line angle formula, we'll have 1, 2 carbon. This one is OH. There. For the complete structure, we have carbon, terminal carbon is bonded with 3 hydrogen. Non-terminal carbon is bonded with 1 hydrogen, second hydrogen, and the third bond is with O, and then another is hydrogen. So there. Nomenclature. We have two systems in giving names to organic compounds. Normally, we give nomenclature according to the IUPAC system and common name. So for the IUPAC names of alcohols, we notice that there are similarities with naming alcohols with naming hydrocarbons. So whatever you learned from the system of naming alkenes, hydrocarbons, and other hydrocarbons, we have similarity now in giving names to alcohols and in most other organic compounds. So it is too important that you know how to name alkanes because alkanes are the backbones or where the other organic compounds are derived from. That's why these other compounds are also called hydrocarbon derivatives. So from the original hydrocarbon, we derive, for example, an alcohol by simply removing or replacing some hydrogen with a group of atom, an atom or a group of atom are called functional group. According to the functional group is the set of physical and chemical properties. So if it's alkanes with no functional groups, then they exhibit physical and chemical properties that are different from the set of physical and chemical properties when you transform that alkane to an alcohol by, say, removing one hydrogen with an OH or hydroxy group. Okay, so for this one, we have the steps, no, in giving names, IUPAC names for alcohol. So number one, you need to select the longest carbon chain containing the hydroxyl group. You call that the parent alkene, the parent hydrocarbon. You also have to number it according to where the carbon left or right terminal closer to the OH or hydroxyl group. In the next slide, we will have some examples. Number two, you need to add suffix OL to the name of the parent chain. So for example, it is pentane. You will have to replace the last letter E with OL to make it pentanol. So earlier from the previous slide, we have the simplest alkane methanol derived from methane. So from methane, you remove E, the last letter E, you replace it with OL to make it methanol. So that's how we give the IUPAC name for alcohols. And then the carbon bearing the OH group is carbon 1 for cyclic alcohol. So automatically, if your carbon atoms are in close chain, the carbon bearing the OH group, there may be one or more hydroxyl group in the cyclic uh, carbon chain. So if it only has one carbon, that is understood to be carbon 1. If there are two or more, you need to number the chain clockwise or counterclockwise depending on the order that will give you the lowest number of carbon atoms bearing the OH groups. And number three, you need to name and number substituents. So if there are any substituents, alkyl groups, or other atoms, heteroatoms attached to your carbon chain, you arrange them in alphabetical order. Okay, let's have these examples. So in here, you're given the IUPAC names and then the common names in open and close parentheses. So earlier in the last slide, previous slide, you're given the simplest alkane called methane or methyl alcohol for the common name. This set of examples here starts with a 2 carbon atom. So we have carbon 1 and carbon 2 in ethanol. Okay, so notice in the bond angle structure, one of the terminal is already with oxygen. So we assume that only 2 carbon atoms are present. This vertex 1 and terminal are constituting to 1 and 2 carbon atom. So for the IUPAC system, 2 carbon atom gives us the prefix F. From the alkane name ethane, we remove E and replace it with OL to make it ethanol. For the common name, you name the alkyl group. This alkyl is a 2 carbon alkyl called ethyl. Hence, for the common name, you have the name of the alkyl ethyl, and then you add the word alcohol to make it ethyl alcohol. This next example has 1, 2, and 3. Notice that the IUPAC name has numerical number 1, dash, and then the name propanol. Why? Because of isomerism. OH here is bonded at terminal carbon. Whereas in the next example, your OH is bonded to a non-terminal carbon. This one is a primary because your carbon here is bonded with one other carbon. In the next example, your carbon here where that bears your OH is bonded to two other carbon atoms. So secondary, primary. This is primary. This is secondary. Okay. So in these cases, you need to specify the position of the OH group, hydroxyl group. So in this case, in the first example, your OH is bonded at carbon 1. So you call it by the IUPAC system 1-propanol. In the next example, your OH is bonded to carbon 2. So you have to specify that as carbon 2. 2 dash propane means 3 carbon alkane. Change the E to suffix OL to make it propanol. So you call this 2-propanol. For the common system, name this alkyl. This 3-carbon alkyl is isopropyl. So the common name will be isopropyl plus the word alcohol. The next example is a 4-carbon alcohol. 1, 2, 3, 4. So your OH is bonded to carbon 1. So you call it 1. 4-carbon alkane is butane. From butane, you drop E and change to OL to become butanol. So you call it 1-butanol. This alkyl is called butyl. So for the common name, you call this butyl alcohol. The next example, you have OH hydroxy bonded to, this is 1, 2, 3, and 4 carbon. Because of isomerism, your hydroxyl here is uh, changed to, in terms of its position, location, at carbon 2. So you specify the position of your alcohol group, that's at carbon 2, so you call it 2-butanol. For the common name, this time this alkyl is called sec. Sec-butyl is the alkyl name. So you call it sec-butyl alcohol. By the way, in alphabetization of the alkyl or substituents group, only iso is considered in alphabetizing. When you have sec and tert, for example, in the name of the alkyl, you disregard them in ordering the names of the alkyl in alphabetical order. So if it's between uh, butyl and isopropyl, butyl should come first over isopropyl. But if you compare isobutyl and let's say sec-butyl, it's still butyl because again you disregard sec or tert in ordering them in alphabetical order. But comparing between methyl and, for example, sec-butyl, M and then S yung isa, pero you disregard sec, only butyl, it's only between methyl and butyl. So butyl should come first before methyl. So even if your butyl has a sec or tert, we only consider butyl for the alphabetization. But if it's iso, let's say methyl versus isopropyl or isobutyl, it's still isopropyl to come first before methyl. Okay, we only omit or disregard sec and tert uh, in the alkyl name when arranging them in alphabetical order. But iso is considered in ordering of the alkyl substituents. Okay, let's move on. This next example, you have 1, 2, 3 carbon because 1 carbon is in the substituent methyl. It is bonded at carbon 2. Your carbon 1 automatically bears the hydroxyl group. So they have 1, 2. Methyl is at 2, so you call it 2-methyl dash 1 propanol. Your parent chain is a 3-carbon propane. Since this is an alcohol, propanol. It may change position, that's why you need to indicate 1, the position of your OH. For the common name, this alkyl is called 1, 2, 3, 4 carbon is called isobutyl because of the position of 1 carbon in the chain. So you call it in the common system isobutyl alcohol. The next example, you have 1, 1, 2, 3, 4 carbon. Notice that your carbon here is bonded to 3 other carbon. That's why it's a tertiary alcohol. Okay, but in naming, according to the rules or guidelines we had in the previous slide, we have to locate the longest carbon chain. So in this case, what is the longest chain? So obviously, this one, longest continuous carbon chain. Carbon 1 should bear your, or the OH should be closer to, uh, or carbon 1 should be closer to your functional group hydroxy. So in this case, the two terminals are this and this one. So if you are to number the chain, this is carbon 1, carbon 2, and carbon 3. Where is your OH bonded to at carbon 2? What about the other carbon? The other carbon is a substituent called methyl. Where is it bonded? At carbon 2. That's why it's called 2-methyl, this one. And then 2, because your alcohol group, your hydroxy group is attached at carbon 2, hence that is 2-propanol. For the common name, since this is a tert-butyl alkyl, you add the word alcohol, so for the common name, it's called tert-butyl alcohol. If your carbon chain is close, that's why in here you have prefix cyclo, because we add cyclo when your chain of carbon is closed, or your carbon chain is in the closed system. Alcohol or alkyl group is what attached to one of the 6 carbon atoms. So automatically, if there is just one, that automatically gives your carbon here, where your OH is attached to carbon 1. And if there is no other variation for the number, then that is understood. You don't need to indicate here 1 cyclohexane or hexanol becoming an alcohol. After removing one hydrogen and replacing it with OH, it becomes an alcohol. Okay. For the common name, how do you call this alkyl? This is a 6 carbon cyclic alkyl group called cyclohexyl, and then the word alcohol. So this is how you name IUPAC and common names for alcohol. Let's have some examples. More examples. Let's give the IUPAC, just the IUPAC name. Because again, common names are usually given to alcohols of small numbers of carbon atoms. So how do you call these? Always remember that OH should be close to your carbon 1. So if you are to number the chain, should you start from the left or the right terminal? This terminal is closer to your OH, so that is your priority. So we have 1, 2, 3, 4, and 5 carbon atoms in our parent chain. What about this one? This is a substituent. So the parent chain is your alcohol. You have one substituent. You name first the substituent. That is bonded at carbon 4. So you call that 4. 1 carbon alkyl is called methyl. So that is 4-methyl. And then where is your OH bonded to? At carbon 2. So you specify the position. 2. What is 5 carbon alkane? Pentane. So from pentane, you drop E and change it to OL to make it pentanol. So the complete name, IUPAC name for this alcohol is 4-methyl 2-pentanol. Got that? Okay, another one. We have here a closed chain of carbon. So this OH is automatically bonded to carbon 1. What about the other? You number the chain, this in this case clockwise, because it may be counterclockwise depending on which carbon will give you a lower number for the substituent. So the substituent is closer when you number the chain clockwise. So we have 1, 2, 3, 4, 5, and 6. Where is your substituent bonded to? This one. We have 1. What is 1 carbon alkyl? That's another methyl. So that is, sorry, that's 2. Sorry. That is bonded at 2 here, here. 2-methyl, and then you only have one hydroxyl group, so that is understood to be in the closed chain, that is understood to be at carbon 1. So you don't need to indicate 1. So you call it 2-methyl cyclo, 6 carbon cyclic hydrocarbon is called cyclohexane. So from cyclohexane, you drop E and change it to OL to become hexanol. So you call it 2-methyl cyclohexanol. Okay, next, this one, letter C. You have 2, 4, 6, and 7 alcohol. This terminal is the left terminal carbon is closer to your OH. Okay, the last carbon is your 7th. What is 7-carbon alkane? That's heptane. Where is your OH bonded to? At carbon 2. So you call it 2. Heptane becomes heptanol. Okay, heptane because the origin is heptane. So you just need to change E, the last letter E to OL to make it heptanol. And the last one, how many carbon atoms in the longest chain? There are 1, 2, 3 carbon. Isn't it? 1, 2, 3. Okay. This one is already a bonding with OH. So you have carbon 1 here. Carbon 1, 2, and 3. So only 3, isn't it? 1, 2, 1, 2, 3, 1, 2, 3. Only 3 is the maximum number of the longest carbon chain. The two other carbon are in substituents. Okay, you have two similar substituents, both methyl. Where are they bonded to? Both at carbon 2. So you cite them first, 2, 2. Similar dimethyl, to indicate 2-dimethyl, you use prefix di and then the word methyl. Okay, how about um, the OH? Where is it bonded to? Is it possible to change the position of your alcohol group? Probably. So you can cite here 1, 1, 2, 3, so propane, so propanol. But upon checking, upon looking, there seems to be no other way not to change. There's no way to change the position because that will make it a different alcohol because the attachment to carbon 2 will be different if you change the position of OH. So for now, let's consider this as the correct name. Okay, we classify alcohols as primary, secondary, and tertiary. I think we have made mention of this during the lecture and the laboratory. So carbon, um, depending on the carbon where your OH group is attached to. When your carbon bearing the OH is bonded to one other carbon, that is a primary alcohol. When the carbon bearing your OH group is bonded to one and two other carbon atoms, that is classified as secondary alcohol. But if your carbon bearing the OH is bonded to three other carbon atoms, that alcohol is classified as a tertiary alcohol. Okay, let's have some examples. Oh, no examples. There may be 2 or 3 alcohol groups in your chain. Okay, so for example, your ethane um, has 2 hydrogen atoms replaced by 2 OH groups. So how do you name the diol? So you retain the E of your alkene. So earlier in alcohols where there is just one, you drop E in the alkane name and change to OL. But this time you have to complete the name of the alkane. So for example, in ethane diol, you complete the name of ethane, and then to indicate that there are two alcohol group, you add the prefix di and then the suffix OL. So you call this ethane diol. You indicate the positions of OH. Where are they bonded to? Because is it possible that the two OH are bonded to just carbon 1? Yes. So in that case, you have to specify the positions of OH bonded to carbon 1 and carbon 2. So that is called 1,2-ethane diol. The common name is given at ethylene. Ethylene means 2. Acetylene means 3. So ethylene, glycol is given to diol for their common names. Okay. Let's have the 3-carbon diol. Ayan. So, originally from propane, you replace 2 hydrogen atoms with 2 OH. Can we say that OH may change position? Yes, they may be bonded to the same carbon. Pwedeng terminal carbon pareho or in this case, at carbon 2 and carbon 1. Pwede rin namang at carbon 1 and carbon 3. So there are 3 possible positions or connections for the 2 OH groups. So in this example, you have carbon 1, carbon 2. Again, you have to name to number the chain where your carbon 1 gives your OH alcohol group or hydroxy group, the lower number. So you have here 1, 2, the parent chain is propane, and then you add di, and then the suffix ol, so you call that 1, 2 propane diol. The common name is propyl, meaning 3 carbon, and then glycol. Glycol meaning 2 hydroxyl groups in the chain of carbon. And then we have here 3 hydroxyl groups attached to 3 carbon atoms. So again, the positions of OH may be different. No? There may be another structure where the OH groups are bonded to other carbon atoms or change connections, no, with the carbons. So in this case, the OH carbon are bonded to 3 carbon atoms in the chain. So they are bonded to 1, 2, 3 propane. Since there are 3, you add tri and then the suffix ol to make it 1, 2, 3 propane triol. The common name given here is glycerol or glycerin.